Good morning. Having coffee and thinking science. Um, so, magnets. What are magnets? They will tell you that we align the shared valence electrons, and we align their magnetic moment to make a magnet. Um, so, that's not how magnetism works in any way, shape, or form. Let's start off with what are we actually aligning? So an electron, we claim, is a dipole magnet floating around the positron and the neutron inside the core. And it floats around in this cloud and generates electricity. And it travels to and from the cloud and goes up and down, and we call this electricity, but this is not electricity. This is not how magnetism works. When we align the magnetic moment in a crystalline structure, what we're doing is we're aligning the dipole magnets inside the nucleus. What do I mean by dipole magnets inside the nucleus? So if you take those electrons and protons and recognize what they are, which is dipole magnets, you can stack them together, and that creates very particular structures. And how these structures interact with their surrounding determines what kind of an atom you have and how it interacts. But it also generates a magnetic field around itself, a magnetic sphere, if you will. And that sphere we call the electron cloud. And that electron cloud is actually just electromagnetic field, right? And the electromagnetic field line, when you get bigger magnets, and you rotate those around a wire, it looks for just like any energy, it looks for the easiest pathway to follow. And a wire made out of iron, has a crystalline structure made up out of these dipole magnet structures, and we can reverse their polarity. Meaning, we could take a magnet on one end of that entire wire system and put it close, and it'll pull the protons and point them. Protons. It's actually, I still call them protons. The dipole magnets in the core of the nucleus. It aims them. It turns them. They're able to turn in certain metals, and when they have a shared energy field, you can use a magnet to pull the polarity or turn the magnet around, and it turns the magnet around inside the entire system. And this is what we call magnetism when we run it down, when we run the magnetic field line down the metal wires. This is what we call electricity, is that constant pulse back and forth of the magnetic field inside the nucleuses across the entire metal lattice. And by doing this, we allow ourselves to use a rotating magnet to generate a rotating magnet at the other end as an electric motor. We can do all kinds of things with this concept, and we have. And oh my, have we done a lot of things with electricity. But at no point does a charged particle electron run around doing anything. What we call the electron is actually the magnetic field line. And it's controlled by the nucleus. It's not the cloud. It's not the field line itself. It's the nucleus of the atom that is dipole magnets in very particular structures that make very particular shapes that interact with its surroundings in very particular ways. And by teaching children over and over and over again for over 100 years that it's magically different in an atom than it is everywhere else in the universe, we are teaching them a false, it's broken down to a religion at this point. We are forcing a religious belief on atomic structure upon children, because all children learning about magnets ask questions, and they're all told the same lie over and over and over again. And as they're trying to show the truth and they're trying to investigate, you tell them, stop, memorize this for the test, you're wrong. And the end result is they're not wrong for questioning. Our understanding and our teachings about the nucleus and the atom itself, the atomic structure, is incorrect. And we got to start, we got to bring back mechanical realism and recognize what is actually going on, rather than shut up and calculate, which is the common idea today. That the big thing today is shut up and calculate. The math works, don't worry about why. But if you don't understand why, then you really have no idea what you're calculating. All right? Have some coffee, enjoy your day.